years ago, a book by Thomas Kuhn, The Structure of Scientific Revolutions, altered the way we look at philosophy behind science, as well as introducing the much abused phrase, paradigm shift. A paradigm shift is an important change that happens when the usual way of thinking about or doing something is replaced by a new and a different way. A paradigm shift can happen within a wide variety of contexts. They very often happen when new technology is introduced that radically alters the production process of a good or service. This concept was introduced by Thomas Kuhn, the well-known physicist, philosopher, and historian of science who was born 94 years ago today. Kuhn argues that the world or reality cannot be described independently of the conceptual schemes through which we observe it. Paradigm theories are a part of a conceptual schemes. So when a paradigm shift occurs, in some sense the world changes. Paradigm theory is a general theory that helps to provide scientists working in a particular field with their broad theoretical framework, what Kuhn calls their conceptual scheme. It provides them with their basic assumptions, key concepts, and methodology. It gives their research its general direction and goals. It represents an exemplar model of good science within a particular discipline. A paradigm shift occurs when one paradigm theory is replaced by another. There are plenty of examples of paradigm shifts, but the one we're going to look into today is about Sir Isaac Newton's theory of gravity and Albert Einstein's general relativity theory. In the 17th century, Sir Isaac Newton, in his law of universal gravitation, defined gravity as a force attracting one object to another, the strength of which depended on the masses of the objects and the distance separating them. Newton's law was widely lauded as it explained many, if not quite all, observable gravity-related phenomena. In Newtonian physics, length and time are absolute, so the length of an object in one frame is the same as the length of that object in another frame. Also, time passes in the same way in one frame as in the other frame. By the end of the 19th century, there was a crisis, a failure to understand the motion of light. This problem was solved through a paradigm shift, a revolutionary revision in the understanding of space and time carried out by Einstein in the decade between 1905 and 1915. Albert Einstein published his theory of general relativity. The theory proposed that gravity is not a force, but the result of curvature in space-time caused by objects that have mass. Einstein's theory of relativity then became the new paradigm, and the study of motion and gravitation entered upon a new period of normal science. The paradigm shift of general relativity was responsible for a number of scientific new beginnings. It led to a completely different interpretation of events around us, but also provided an explanation for some baffling or yet to be discovered phenomena, from the anomalous orbit of the planet Mercury through the bending of light by the sun's gravity to predicting the existence of black holes and expanding universe. This is an example of an important type of paradigm shift. The new paradigm explains more things, and from it, the old one can be derived as a consequence, a special case, or an approximation. This is what a paradigm shift originally meant, and what it still means in the philosophy of science. When used outside of philosophy, though it often just meant a significant change in theory or practice, So events like the introduction of high-definition TVs might be described as involving a paradigm shift.